Regnans here, and today I'm going to talk about the chunk loader for my project Abstract Serenity. So you can see all these solid walls that are popped in. Each one of these is a chunk, and you can see that as my ship goes around, new chunks will spawn in, and if I drive away from an old chunk, it's going to disappear. Also, if you watch like one of these chunks down the bottom, I'll go up and I'll drive away. Remember what angle that was at. And if I come back down, it should spawn in exactly the same angle it was. And this is because each of these has a pseudo-random number created from a SHA-1 that's based off its location in the world. So where the object is determining its rotation in a haphazard way. And I'm planning to use this for procedural generation. If I just go into the code and I increase the distance between chunks up to 1,500 and the distance at which they're disappearing up to 4,000, I can show you something that is more like what I intend for the finished product, where there's reasonable spacing between chunks. You don't see any of the visual of chunks loading in or out. They load in off screen, and chunks clean up and are destroyed to free system resources so your computer can run nice and fast for stuff that's not on screen that you don't need to worry about in the game. So this has been the biggest thing I've worked on today. This and the rather dull debug log that I've got up in the top left. But I've been really excited and actually quite happy with the code that came out of this. So if I back out and go across the code, I could talk through a little bit of how I built this. So we have this class up here that does coordinate transformation. And what this allows me to do is turn floating point positions, like where my player is, into integer positions that we can think of as a grid. So imagine there's a chessboard and every 100 meters is a square. By transforming the exact place where the player is, which is a floating point value, to an integer, we lose a little bit of precision, but we know exactly which square we're on. And that's all we need to know which chunk we're on. And so the chunks are stored as integers. And I have this little function here that takes the x and y coordinates for a chunk and combines them into a single uint64 value. It doesn't really matter that this is an unsigned integer. It's just about joining those two smaller values together to make them one value. Because what that lets me do is store all the chunks that are currently loaded into the game in this dictionary class, which allows me to look them up by their location, which is stored in this uint64. So what happens is there's a little bit of preparation when the game first loads, and then every frame of the game we get where the player is. We check if any of the chunks that we currently have loaded are more than the culling distance away from the player. So at the moment this is 4,000, which I think of as 4,000 centimeters away from the player. And this means they'll be off screen. And if they're off screen, we can remove them so that we don't have thousands and thousands of chunks building up, taking up all our system resources. We can get rid of the ones that are far enough from the player, and that allows us to have a really open, expansive universe. This bit of code. This bit of code just creates kind of like a noughts and crosses grid. It works out what all the locations on that noughts and crosses grid would be around the player. So you'd have the player's location, maybe they're at 1,000 up and 500 to the right. And so we're going to create a grid that's got 1,500 in the center, and then you'd have, I said 1,000 up, didn't I? So you'd have like 999 through to 1,001 going up, and 499 to 501 going right. So you'd have a grid. And these are the 9 squares, the one that the player's on, and the 8 around them, that need to have a chunk running at all times, because either you're in a chunk and that needs to be, the chunk you're in needs to be on screen, or the chunk to the right of you that you're about to drive into needs to be created so that it can also go on screen. So here I'm determining what those positions are, and then down here I convert those positions into the unsigned integer format that I can then use to look up the dictionary. And if they're not in the dictionary, there's just a bit of code to create a new chunk, and the chunk gets told that it's getting created, and it's also told how big the chunk is, which doesn't really matter too much. It's just a little thing that needs to be passed over to it. The only other little thing that's in here is that when chunks are deleted, they're also told that they're being deleted, so that if they need to clean up afterwards, they can do it. And if I go over to the very simple code that my chunk has, when it's created, it knows where it is. It creates this unsigned integer, which is the same as the coordinate that I was talking about before. This is just where it's going to be on that grid. And then it uses a SHA-1 to create a hash from that coordinate. A SHA-1 is a cryptography algorithm, so you might find it in something like a web browser where you're trying to talk securely with a website. And what it does is it takes something like a plain text password and turns it into gibberish. And here I'm taking a very simple number. It's numbers like 1, 2, 3, 4, 5, and then I've added another number to that side by side to make this coordinate, because this is just the x and y coordinates stuck together. But the SHA-1 will turn that really uniform structured number into gobbledygook. And because of that, the output is nearly random. But the beautiful thing about the SHA-1 algorithm is the output will be the same for a particular coordinate. So if I put the number 0 in here, this SHA-1 will always give the exact same output. If I put the number 1 in here, this SHA-1 will always give the exact same output. And what that means is, while I can use this to have a random-like outcome, it's always going to be the same every time. So I can build off that, and I can work with that in my game design. And all I do with this at the moment is I just take the first little bit of it and use it to randomly rotate the wall object. And here's just the bit that puts in the text. That's that green text label underneath each. And as I showed earlier, when the chunk goes out of range, it is deconstructed by calling this method, which just puts something to the log. So yeah, thanks for watching. See ya.